9.4, we will be talking about ellipses. You may have seen them before and called them ovals, and that's okay. An ellipse actually has a specific geometry definition that I'm going to come back to. But we're going to look today at how to graph ellipses, which we won't be using their geometry definition for. But I'm going to talk about it anyway. We're going to write equations for ellipses. There's a couple ways this work out, the various features that you might be given, and you need to be prepared either way. And then we're going to talk briefly about distinguishing ellipses from circles and parabolas, because once again, there's a section at the end of your homework where we're going to be given a set of problems without being told which type it is. You need to identify the type of graph so that you can put it into the correct standard form and produce the graph. So, getting right into it, to graph these, the way the ellipse works is unlike the circle, which had x and y kind of by themselves because there was one set radius. An ellipse is elongated. I'll draw one with a horizontal major axis. So an ellipse actually doesn't have one center. It has two important points called foci. That's the plural for focus. So there's a focus over here and a focus over here. We call them foci. Now the distance between the foci and the center is an important number in this case. It's going to be the kind of like p from our parabolas. It's the distance. The definition for an ellipse is actually the set of all points that if you add up the distance between the two foci and that point, you're always going to get the same number. So the distance, the sum of these two distances is the same anywhere on this circle. I'm sorry, not circle, anywhere on this ellipse. The sum of these two distances. And so any point you pick, the sum of those distances is going to be the same. And that's actually what makes this an ellipse. The closer the foci are to the center, the more it looks like a circle. In fact, a circle is basically an ellipse where both foci are at the same point. Then the further out they get, the more elongated the ellipse gets. Okay, so in order to figure out what's going on with the ellipse, because the horizontal and the vertical axes are not the same, we're going to end up actually with these fractions, because instead of the r squared being on the other side, it's going to be underneath the x and the y respectively. The width of the distance from the center to the vertex, the end point right here, the distance in the x direction is going to be underneath the x, although it's going to be squared. So just like we did with the radius, this is called the major axis. Well, I guess it's the semi-major axis. The distance from the center to this vertex is a. Let me actually draw another one here. I'll draw this one vertical. So in this case, the distance from the center up to the vertex here on the top is going to be a. That's called the semi-major axis. The major axis is the long one, which is actually 2a. And then the semi-major axis is just half of that, when that's a. And then b is the other distance to this on the closer side, which we call a co-vertex. So vertex is further away. The co-vertex is the closer one. When you're trying to find the foci, it matters which one's the x and which one's the y. But the vertex is always the larger of the two. So your book is always going to call it a. And so whichever one of these is the larger number is the one that your book is going to call a. And then the one that's the smaller number is the one that your book is going to call b. But the one that's under the x is always how wide your ellipse is, and the one that's under the y is always how tall your ellipse is. So let me show you how this works out with an example. So first we're going to graph 25x squared plus 4y squared equals 100. Now the first thing we note is the x is squared and the y is squared. Their coefficients are not the same, which is how you're going to tell it's not a circle, because the x coefficient and the y coefficient are not the same. So I'm going to go up here and note the standard form requires a 1 on the other side, so I have to divide by 100 in order to make these in order to make this 1. And that's an important step because it's going to give you the correct fractions over here. 25 divided by 100 is 1/4, and 4 divided by 100 is 1/25. If you like, you can actually divide these upside down to figure out what goes on the bottom. 100 divided by 4 is 25. 100 divided by 25 is 4. Sometimes these will be irrational as well, so you should be prepared for that. Oh, I'll make sure to do at least one example like that. In this case, then, A is the larger of the two. A is 5, because 25 is 5 squared. B is going to be 4. Also, A is under the y squared, which means this ellipse is going to be taller than it is wide. My center is at 0, 0. All the centers in this section will be at 0, 0. So my center starts at 0, 0. The y's are going to go up and down from my center. It's going to go up 5, 2, 4, 5, and down 5. But the b is only, I wrote 4. The b is only 2, so it's going to go 2 to the right and 2 to the left. And then I can draw my ellipse. So the situation is somewhat complicated as far as how the x's and the y's interact, but drawing the ellipse is fairly straightforward if you can get it into standard form. You remember to take the square roots of the bottom, but the one under the y is how far up and how far down you go from the center, and the one under the x is how far right and left you go from the center. Graph equation. Okay, let me do one that doesn't work out quite so nicely. X squared over 30 plus y squared over 8 equals 1. Now in this case, my axes are going to be irrational. So I think about the square root of 30, which is pretty much dead center between 25 and 36. So it's going to be really close to 5.5. The square root of 8 is really close to 3. So I'm going to approximate it at about 2.9, because 9 would be 3. Might be better off at 2.8, but for this graph it's not really going to matter too much. Now in this case, the number under the x is the big one, so that's A. And so my ellipse is going to be wider than it is tall. 5.5, 2, 4, 5.5, 2, 4, 5.5. So this is the square root of 30, 0. And then this should be here, which is 0 square root of 8. And down here, there's my ellipse. Your instructions may ask you to identify the foci. Notice the vertices are the ones that are further away, which I didn't label on here. In this case, well, stick here. There's negative square root of 8. Okay, so these are symmetric. The vertices for this one are square root of 30, 0, and negative square root of 30, 0. The co-vertices are 0, negative square root of 8, and 0 square root of 8. In this problem over here, I forgot to do them. But the vertices are at 0, negative 5, and 0, 5. Because it's taller than it is wide, the vertices are on top and bottom. The co-vertices are at 2, 0, and negative 2, 0. Finding the foci takes an extra step, but there's a little equation that will always work, which is c, which is the distance to the foci. C squared equals a squared minus b squared every time. And this is why it's important that a be bigger than b, because you need to subtract the smaller one from the bigger one so you get a positive answer. That's the only reason why it's important to know which one is a and which one is b. Well, I guess identifying which are the vertices, but you can do that just by looking at the graphs. But you need to make sure you do the big one minus the small one so you get a positive number so that c is real. And for our first example, c squared equals a squared is 25, b squared is 4. So c squared is the square root of 21. Typically speaking, except in very rare occasions, at least one of these three numbers is going to be irrational. So be prepared. Now this is a number, it's bigger than 4. Right? 4 squared would be 16. 5 squared is 25. So it's closer to 5 than it is to 4. And that is not unusual for ellipses. This ellipse is pretty elongated, so the focus is going to be really close up here to the vertex. The focus is at 0 square root of 21, which is quite close to 5. And the other focus is at 0 negative square root of 21. In this example, which is similarly elongated, c squared is going to equal 30 minus 8, which is the square root of 22, which is, again, more than halfway to 25. Or I should say to 5. But it's between 4 and 5, but it's closer to 5 than it is to 4. Square root of 60 is on the other side of 5. So here, square root of 22, 0 is one focus, and the other one's over here, negative square root of 22, 0. It's not a bad idea to label your foci by putting an F in front. If you want, you can put V in front of the vertex as well. I should be able to figure them out as long as your graph is legible. Or you can always write the points off to the side for this. I'm not that concerned. Just make sure you also put a little dot on the graph. So you should be able to find the vertices, co-vertices, or focus for any given equation. Number 2, write the equation. There's really two ways this works out. You could theoretically do this given a co-vertex and a focus. Any two of these numbers is enough to write the equation. A, B, and C. The vertex, co-vertex, and focus. Technically for this you need to know the center, but as I keep saying today, our centers are all at 0, 0. So let's start with an example where we have a vertex and co-vertex. So let's put the vertex at 0, negative 7, and we'll put the co-vertex at 4, 0. Now the vertex being at 7 lets us know that A, or I should say negative 7, A is going to be 7, and the co-vertex at 4 tells us that B is going to be 4. The other thing I see is that the vertex is in the y direction, it's down, which means the A is going to be underneath the y. The co-vertex is to the right, so it's going to be underneath the x. And that's actually all the information I need, because the standard form has a 1 on the other side. I'm going to put my x squared, and underneath it I need 4 squared, which is 16. Then I'm going to have my y squared, and underneath it I need to square 7, and I get 49. So given a vertex and a co-vertex, it's actually the fastest way to write the equation. Frequently, though, you are given instead the vertex and a focus. So if I have instead a vertex and a focus, 0, 10, and 0, 8, the vertex and the focus will always be in the same direction. The vertex being 10 tells me that A is 10. It also tells me that the 10, or well, it's going to be 100. It's going to be under the y squared. Now, in order to find B, I'm going to need to use my c squared equals a squared minus b squared equation. So c squared is 64, because that's 8 squared. A is 10, so this is 100 minus b squared, which means if I subtract 100, I'll get negative 36. That equals negative b squared, so b is going to be 6. Because change the signs and then square root. So b is 6, and because a is in the y direction, b must be under the x. So x squared over 36 plus y squared over 100 equals 1. So the focus is useful for finding the covertex, but I don't need it really for the equation, or it's not in the equation anywhere. All right. So using you need A and B in order to write the equation. If what you have is C, the focal distance, then you can use it with one of the others to find the third. So we're squeaking. Okay. Vertex, covertex. That was number 2. 3 was distinguishing ellipses from circles and parabolas. Remember, parabolas, you're going to have only... You're going to have one squared variable and one not squared variable. For circles, the x and the y will both be squared, but you'll either have, well, they'll have the same coefficient. So in standard form, that means the x and the y each have a coefficient of 1, and you have just one radius on the other side. If it's not in standard form, you may see something like this. I don't know. Wait, 6 times 24 over. Wow. Okay. You may see something like this. 6x squared equals 24 minus 6y squared. Where they're not on the same side yet, but we're going to put them on the same side, but their coefficients have the same value, which is how you're going to tell a circle apart from an ellipse. Because a circle, they're going to be the same, so you can divide by 6 and get your standard form for your equation. For an ellipse, what you're going to see is that the coefficient of the x squared and the coefficient of the y squared are not the same. So in that case, you want to get a 1 on the other side to produce your fractions that are informative. 4 divided by 24 is 1/6, and 6 divided by 24 is 1/4. So this is an ellipse. Right, and so then 6, well, the square root of 6 is how wide it is, and 2 is how tall it is. Okay, that should be enough to get you started for ellipses. So good luck.